Hello. Welcome, my friend. How are you? I hope you are well. We are together with a question beyond perfect. Look, it looks like a logarithm question, but soon. It will take gold to very different places.
Wow.
Please carefully 1. Watch now, what did he give us first in the question? X of a and b of positive real. He said it was a number, then logarithm x base of a. Logarithm base x of b, logarithm in base x of a plus b, said it was sorted from small to large. And also these. Of course, I didn't write that part. Says there are consecutive integers. And the logarithm from us is 2 times x plus 1 at base x, want us to find. Now what should I think about here first? What is the difference between consecutive integers? For example, if we think about it, let's take 3 and 2. These two numbers are consecutive numbers. What will be the difference between them? 3 minus 2 to 1. Then when I separate these friends, look at this. What should he do with this feature? Must provide. Then I say logarithmic. Base x a plus b minus. Logarithm base xb must be equal to 1. Same way. What can I say after writing this? Also logarithm. If we remove this part, yes, logarithm x base b minus logarithm x base a. I would say 1 is equal. Now I'm going to try to get something from these two equations. Now you know logarithm had a feature. Let's remember him. What are these features, logarithm? Base a minus b. Logarithm, the expression we call c in base a. Logarithm base a divided by b, we could express in the form of c. Come on now, in these two equations, for example, the first equation. If we call this the second equation, let's apply them. What can I say now? Logarithm in base x. I could say b over a is equal to 1. 1 in the other equation. Logarithmic. X base a plus. I'd say b over b is equal to 1 again. What will be the feature of logarithm? The expression we call b divided a comes from here, x, again due to the feature of logarithm. A plus b over b is equal to x. Let's edit this a little more. It wouldn't be nice to stay like this, so we can write them separately. So a dot b plus b dot b is equal to x. What happens in this case? 1 plus a over b is equal to x. Look at us, two different. One algebraic expression output. I can tell you what they both equal. Now I can say that x is equal to. Here it says b over a, here it says a over b. Look, if I change it a little. I'm doing somersaults. Isn't the expression I call a b 1x? This is the friend I found. I take it and write it instead of this equation. So what's up, 1 plus 1 over x is equal to x. What can I do later? Both sides and both sides. Multiply by x, x plus x times 1, x, equals x squared. If we arrange a little more, look, if you pay attention, friends over there, it will go what happened. X plus 1 is equal to x squared. Let's edit some more. X squared minus x minus 1 is equal to 0. We found your equation. Look. Let's remember, if we want to find the roots of this friend, we will go to the first head delta of this. What about the friend we call delta b square? Minus 1 squared minus 4 times. 1 times minus 1. 1 plus 4 to 5 is greater than 0. What do we call x1 to 2? 1 plus root 5 to 2. So what was 1 plus root 5 to? Friends at the golden rate. Actually, look at the question. We started with logarithm. Where did this question take us? If you pay attention, it took gold to the ratio. So I get it up. Can I solve this question by substituting the logarithm? So think about it. What was the logarithm value he wanted from me? The logarithm was 2 times x plus 1 at base x. I'm bringing it here. I'm writing the place to the value I see. Logarithm 1 plus root 5, of course, there should be a minus here. I forgot to write. Divided by 2, then 2 times open brackets. Plus minus root 5, dan bu. Here, plus 1, so this expression is really hard to calculate. Then it's mine. I need to reconsider the equation here. So what do I mean? I got this. Look what I can do about it. X squared equals x plus 1. Look at that part of the logarithm. Friend over there. How would it be if I changed it a little? So if I try to write like this, logarithm x base x plus. I can write this question as x plus 1, right? What can I do later? Logarithm in base x. X plus. Look where I saw x plus 1 if you pay attention. This statement. I can write this, what will it be? X will be square. If I continue a little more, logarithm in base x. Look up, I got the x bracket. What came here? X plus 1 is here. Please pay attention here. Look again, what can I write where I see x plus 1? Logarithmic. I can write x times x squared at base x. So what does this take me to logarithm? X becomes x cubed at base x. What can I say due to the feature of logarithm? Remember, logarithm had properties. I'm throwing over a squared of a. This was falling as a top product, only 2. Then because this result from here falls in front of it 3 times. Logarithm x base x. What will this friend over there be equal to? Will be equal to 1. So our answer is 3. Where did this question bring us? But one of the things I really want to say here, look, I explained this in my previous videos. Phi, so what was the expression we call the golden ratio, our friends? This is important for us here. Square of the golden rate, friends. 1 plus the ratio of gold is equal. Please, but please pay attention to this. So I'm here 1 plus, root 5 2 when I square 1 plus. Remember that I can get root 5 divided by 2 plus 1. Friends, if you like the video, don't forget to like and comment. Please subscribe to my channel. Perfect but beyond perfect, one question. See you, bye-bye.